Today we are going to learn about scale factor. Learning target is that you can use scale factor to dilate shapes and solve problems involving scale drawings. So scale factor is difference. Blank scale factor is greater than 1 and it makes the shape greater. So that's an enlargement. And then a scale factor less than 1 is a reduction, or we reduce it. And scale factor equivalent to 1. It's equal. Finding scale factor is a ratio of new over original, or new over old. So we sometimes abbreviate this as scale factor equals N over O. So example 1 is that Charlie's going to make a map of his house for a project. His project has to fit on a poster board that is 3 feet long by 3 feet wide. So it's super important to draw what's going on. So it's saying that this poster board is 3 feet long and 4 feet wide. His house measures 300 feet long by 400 feet wide. What scale factor should he use? So it's also important to write what we're looking for. In this case, we're looking for scale factor. So when asking for scale factor is new over old or new over original. So then we have to decide what came first. Did the house come first, or did this poster board that he's using come first? So the house came first, right? So this is old or the original. And the poster board is new. So this is the poster. This is the house. So then now that we have our new and old, you're going to pick one of the sides. So I'm going to go with the 4 and the 400. So 4 and 400 is what I'm going to use. It's new over old. So that is 4 over 400. So they have to be from the same side. I couldn't use 3 and 400 because that's not measuring the same side of what we're talking about. And then I simplify. So 4 divided by 4 is 1, and 400 divided by 4 is 100. So your scale factor is 1 over 100. So then we decide, does that make sense to have a scale factor of 1 over 100? Yes, it absolutely does, because we went from something really big to something really small. So this is what we call a reduction. So it makes sense. Number 2, using scale factor. So when given the scale factor, we multiply the dimensions by the scale factor. So it says write an equivalent proportion to 5 over 6 by using a scale factor of 3. So scale factor of 3 means that we multiply by those dimensions. So this is times 3. Well, what we do to the bottom, we have to do to the top. So really, 5 over 6 is multiplying both of these numbers by 3, which gives us 15 over 18. And that is our equivalent proportion. Using proportions to solve problems with scale factor. So Marie has a small copy of Renee Margretti's famous painting, The Schoolmaster. Her copy has dimensions of 2 inches by 1.5 inches. So again, 1.5 by 2 inches. The scale of this copy, so 2 and 1 have to be the same place, and 1.5 and 40 have to be in the same place. So really, this is actually bigger because it's inches. So 2 inches, doesn't matter really what side you put it on, as long as you put them in the same place, by 1 centimeter and 40 centimeters. So 2 has to be in the same place as 1, so the 1 goes right there, and then the 40 goes right there. Find the dimensions of the original painting. So both of these are copies. I just realized that I misread this. It says the scale of the copy is 1 inch to 40 centimeters. So we need to know that the scale is 1 inch to 40 centimeters. This right here is completed in inches. So find the dimensions of the original painting. We know that we have 1 inch to 40 centimeters. And if we set up a proportion of inches to centimeters, from the copy that she has, 2 inches is equivalent to X centimeters. So here we're just cross multiplying. 1 times X equals 2 times 40. And so therefore X equals 80. What is 80? 80 is centimeters. So that's dimensions of the original copy of the book. For that length. And then if we wanted to take and find out the 1.5, we could use that same proportion. 1 inch over 40 equals 1.5 over X. And again, if we cross multiply, X equals 40 times 1.5. And then 40 times 1.5, one number to the right of the decimal. That's a 20, 0, 4, 600. And then we have to put our decimal back in, so X equals 60 centimeters. Diego uses a map to determine the distance from his hometown to the nearest beach. The map uses a scale of 1.5 inches equals 45 miles. So if Diego measures the distance on the map to be 6 inches, how many miles does Diego have to travel? So 6 inches equals how many miles, essentially, is what we're trying to figure out here. So we're going to take our scale and set up a proportion, again, using inches over miles. So if we want to figure out this distance by looking at a map, which, yes, we used to have to do this before our fancy GPSs came out, we would have 1.5 inches over 45 miles looking at the scale. And then we know that it's 6 inches in distance, and we want to know how many miles that is. So here is a simple cross multiplication of 1.5x equals 45 times 6. We know how to do this, so I'm going to go ahead and have you press pause and solve this and tell me x equals blank miles. And then we will check this in class tomorrow. So go ahead and press pause and solve this. And press play when you have finished. Okay, last example. Anissa loves boats, and she creates a scale drawing of a boat with a height of 3 centimeters. So we know Anissa's boat has this height of 3 centimeters. if the scale she used was 1 centimeter equals 1.5 meters, what is the height of the actual boat in meters? So again, this is about setting up a proportion using this word ratio of centimeters over meters. We know that 1 centimeter is equal to 1.5 meters, and we know that Anissa's boat is 3 centimeters, therefore how many meters is it? Again, we have cross multiplication of x equals 3 times 1.5, and x equals 1.5 times 3, one number to the right of the decimal. 5 times 3 is 15, 3 times 1 is 3, plus 1 is 4, and then place your decimal back into the problem, 4.5 miles. Important things to remember is that if it asks you for scale factor, and what that is, you're going to have a ratio of new over old. And then we can use scale factor to form a new figure.